All right, today we're going to talk about something that protects you online every single day, probably without you even knowing it. It's called hashing. The best way to think about it is like an unchangeable, totally unique digital fingerprint for your data. Let's dive in.
So let me start with a question that sounds kind of like a riddle. How can a website possibly know you've typed in the right password if they don't actually have your password stored anywhere? I mean, think about it. It seems impossible, right? Well, that's the exact puzzle we're going to solve.
You see, the problem is just massive. We live in a world of constant data breaches, and if every website just kept a big list of everyone's passwords, a single hack could literally ruin your entire digital life. That's what we call the billion password problem.
And here's the big secret, the first clue to solving that puzzle. They don't store your password. Seriously, when you type in, super secret password 123, the website servers do not save that phrase. They save something else entirely.
So what do they store? Well, instead of your password, they keep its unique digital fingerprint. Just like a real fingerprint, it's a one-of-a-kind identifier, but it's not the thing itself. And this, right here, is the core idea of what's called a cryptographic hash.
So, what is a cryptographic hash really? Well, it's made by something called a hash function. The easiest way to picture it is like a magical blender. You can toss anything into this blender, a single word, a picture, heck, even an entire movie, and what comes out is always a string of letters and numbers that's the exact same length. That string, that's the digital fingerprint.
Now, a lot of people get hashing mixed up with encryption, but they do totally different jobs. Encryption is all about hiding data. It's a two-way street. You can lock it up, but if you have the key, you can always unlock it to see the original message. Hashing, on the other hand, is for verifying data, and it is a one-way street. There's no going back.
And this is the absolute most important thing to get about a hash. It is irreversible. Once you turn your password into that digital fingerprint, there is no unhash button. You can't put it back in the blender and get your password out. It's a one-way trip.
Okay, let's see it in action. If we take the simple word password, all lowercase, and run it through the function, it spits out this long, jumbled-looking string of characters. That is its unique fingerprint. But here's where it gets really interesting. Watch what happens if we change just one single thing. We capitalize that first P. The hash that comes out is completely and totally different. This is called the avalanche effect. Even a tiny change on the way in creates a massive, unpredictable change on the way out. And that's crucial because it means hackers can't just guess their way to your password. There are no patterns to follow. So the main takeaway, the golden rule of hashing, is just this. It's a one-way function. You can always get the fingerprint from the data, but you can never, ever get the original data back from the fingerprint. Your secret stays safe. Okay, so we've got this super powerful one-way function. That's great. But how does that actually protect you when you're just trying to log into your favorite app? Let's walk through how it all works together.
The login process is actually pretty genius in its simplicity. So first, you type in your password. The website system instantly runs what you just typed through that same hashing blender. Then it just compares that brand new hash to the one it has on file for you. If those two digital fingerprints are a perfect match, boom, you're in.
And here is the magic of the whole system. Let's say the worst happens. A hacker manages to break in and steal the website's entire user database. What do they get? Not a nice clean list of everybody's passwords. No, they get a giant, messy list of these long, jumbled hashes. And because it's a one-way street, that list is basically useless to them. But of course, cybersecurity is always a cat-and-mouse game, right? Hackers are always coming up with new ways to attack systems. So how do the good guys stay one step ahead to keep those hashes secure? Well, they add a little something called a salt. And no, I'm not talking about the kind you put on your fries. In the world of cryptography, a salt is just a unique, random chunk of data that gets mixed in with your password before it gets tossed into that hashing blender. This one simple step is a total game changer. By adding a different random salt to everyone's password, the final hash becomes unique, even if two people use the same common password, like 123456. This completely defeats a type of attack that uses pre-made lists of common password hashes, making them way, way harder to crack. So we've talked a lot about passwords, and that's probably hashing's most famous job. But it's definitely not the only one. Hashing is also the backbone of something called data integrity, which is really just a fancy way of making sure a file is exactly what it's supposed to be.
Think about the last time you downloaded a big software update. How do you know for sure that it's the real deal from the developer? Or that it hasn't been tampered with, or just got corrupted during the download? Well, the developer publishes the file's hash, its digital fingerprint. After you download it, your computer can create a new hash from the file. If your hash matches the developer's, you know for a fact that the file is authentic and untouched.
And that really just brings it all together, doesn't it? Hashing is this incredibly elegant idea. It lets us prove who we are and prove that our data is authentic, all without ever having to show our secrets to anyone.
So the next time you log into a website or download a file, you'll know there's this invisible, powerful process working behind the scenes to keep you safe. Now that you understand the idea of a digital fingerprint, where else do you think this technology might be used? It's pretty much everywhere.